Please welcome our next speaker, Holden Karau.
Thank you. So this is Debugging PySpark, and it was not actually related to buses. I just didn't realize there was a maximum character count. But I found a Hello Kitty bus, so that works too. And our friend the JVM decided to come along as well. So everyone loves the JVM, right? Okay, 2 people are secretly Java programmers, but it's all right. Yeah, so I'm Holden. My preferred pronouns are she or her, and I'm a developer advocate at Google. I am on the Spark PMC, and I spend a lot of my time in Spark trying to make the experience in Python with Spark less bad. The work is far from finished, and please join us. We can make it a lot better. And there's a bunch of other stuff. If anyone's interested in learning more about the open source process, especially with Apache projects, I've started doing code review live streams. And you can see right now, most of the code reviews are around getting PySpark to work on Kubernetes, because Spark works on Kubernetes, but not with Python. And so you can watch those videos too. In addition to I am professionally, I'm trans, queer, Canadian on a work visa, one of the ones which people are debating if they want to keep or not, which is just so exciting, and part of the leather community. And this is maybe not particularly related to debugging Spark. There is no secret Canadian JVM decoder. This shit makes no sense to me either. But you know, we should be friends and be nice to each other, because this is hard enough without us not being nice to each other because of who we are. Yeah, so also my co-presenter today is Boo. She uses she, her pronouns. She's the author of Learning to Bark and High Performance Barking. You can follow her on Twitter. Unfortunately, her books right now are not mass-produced. O'Reilly did not pick up those ones despite my attempts to bundle them with High Performance Spark. They weren't super interested for some reason. So I'm hoping you're all friendly people. If you object to pictures of cats, this is probably not the talk for you. I'm actually really curious. How many people are completely new to Python? Is there anyone completely new to Python in the room? Okay, cool. Well, that's unfortunate. But if you are new to Python and just scared of saying hi, welcome to Python anyways. How many people already use Spark? Okay. That is a lot of people. How many people do not use Spark? Okay, so I may scare away like 6 Spark developers. This is going to be about the parts that kind of suck. But we're going to work on making them better in the future, and we're going to give you the tools to survive using it today. So I'm going to talk about why PySpark especially is hard to debug. Like some of the design decisions that we made that seemed really good at the time, and then with the benefit of hindsight were maybe not optimal. And then we'll talk about how to look at the logs and how to understand them. We'll talk about why some of the tools that your Scala friends might be using to debug their Spark jobs don't work for you. And I'll also try and get you to use some of my testing libraries and buy several copies of my book. It is unrelated to this topic, but that should not stop you from buying it. Okay, so the key takeaways are debugging distributed systems are hard, debugging mixed language systems are also hard, and Spark is, also lazy evaluation can be difficult to debug, and Spark is all of those things. So we put 3 difficult to debug systems into one system and didn't write a lot of documentation. And now you're all here, yay! And we're talking about some of the things that we can fix, and if anyone's really curious, you can look at some of the mailing list discussions where we're talking about the changes we might want to make to lazy evaluation to make this easier to debug. And so don't feel bad when you get lost, and we'll hopefully give you some tools, Boo and I, but if we don't, I'm sorry. Okay, so for the 6 people, Spark is a general purpose distributed system. It has a Python API. It's faster than Hadoop MapReduce, and I'd like to give a special shout out to MapReduce for setting the bar kind of down here. Really great distributed system. Honestly, sometimes much more reliable, but we run a lot faster because that's just awesome. And we have 2 core abstractions. Don't worry about them. They're both hard to debug. People come to Spark because they're like, hey, this is taking too long. How long can it take to learn Spark? The other reason they come is data frames don't fit in memory anymore in pandas, and they're like, well, Spark has something called a data frame. Let's see if that works. And the answer is almost always no. But at that point, they've invested enough time that they keep going with it and manage to make it work. So Spark is a whole bunch of different components. And this is both really cool and really annoying when it comes time to debug things. We have 2 separate streaming libraries with 4 separate streaming backends. And that's just really hard to know what's going on. We also have 2 separate machine learning models. Machine learning packages, most of which have the same models. And we have a graph system which doesn't work. So if you're trying to use Bagel or GraphX, the first step is to not use it and use something else. Okay, this is a big data talk, so I do have to have a word count example. But I think the part which we can look at here, you know, if you're new to Spark, definitely read the lambda expressions. But this save as text file thing, until that happens, nothing is really happening in Spark. All it's doing is building up a graph. It's like a lazy teenager. It doesn't want to do anything unless you force it. And so we won't find out about any of our errors until we get to this final step. If we did anything wrong up above, Spark is just going to be like, yeah, that's cool. We could have asked it to load data which didn't exist, and it'll just be like, nah, it's fine. And a lot of people will spend time trying to debug their like file output when it's not their file output. It's something else entirely. So we can also think of this. We're going to build our monster identification guide. We're going to figure out how to find the different monsters hiding inside of Spark. There is Mernicorn, which is the combined JVM Python stacktrace. There's Boo, who we have with us today, who is the Python stacktrace. There's FriendMonster, who is the JVM stacktrace, which comes along with every error message in Spark because they don't want your Python stacktrace to get lonely. And then there's everyone's favorite exception in Spark, and that's the out-of-memory exception. And that's Tubbs. Tubbs likes eating all of the memory and then not giving it back. Never. Garbage collection is too much effort. And then there is Buddy, and Buddy represents the Spark logging system. And Buddy is a very yappy dog. Buddy likes to tell us exciting information, like the fact that we're connected to a cluster, and we are still connected to that cluster. And by the way, did you know you submitted a job to the cluster? So really high quality information there. Okay, so where do we go and find our logs and error messages? So if you're running like /bin PySpark, you'll get some of your error messages reported to your console. Are there any Jupyter users in the house? Cool, I'm sorry, but we fixed some things and we'll talk about that really cool. Most likely though, the error messages which you get to your console are going to be kind of overwhelming. And for the people that run PySpark directly on their machines, you've probably noticed that the amount of logging information you get, even when things haven't gone wrong, is overwhelming. And so most people end up turning down the logging level in Spark just so that they can actually see what's happening. And that's cool until things go wrong, because we put like everything at the same log level because we're not good engineers. And we'll fix that. Okay. So before we dive too deeply into the logs, what I want you to do is think about what your program is trying to accomplish. Think about where things might be broken, and then go and look in the logs and see if they match your mental model of your program or what you think might be broken. And this can be really good because normally what will happen is you'll read your logs and you'll be like, I didn't think I was doing that. And that's a good sign that that's the part you want to focus on. Because in Spark we can see lots of exceptions and lots of things which look really important, but they're not. And so we can't just rely on the log level information to tell us which pieces matter. We have to spend a lot more time constructing our own internal model. If anyone's working in Yarn, there's a magic configuration value that you get to set called debug delete debug delay seconds, and this is so that Spark will not delete your container before it has a chance to get the logs off of it when your container crashes. And you also really want to set up this thing called the Spark history server. It is amazing. It lets you go and look at the logs for your program when it's crashed. If you don't look at it, you can only have the logs when it's working, and that's maybe less useful. We want the logs definitely when we've crashed. And if you're working with a commercial vendor, they probably have their own equivalent to the Spark history server that you should use. Right. So buddy is pretty verbose. We can change the log level with sc.setLogLevel. And I think this is important and useful because while we can change it with XML files, those are XML and not a lot of fun to edit. And also I can dynamically change it when I'm working in my notebook or shell to a higher log level when I get to the part of my code where I'm not super sure what's happening. So, okay, what happens when we actually get an error message? Python Spark errors come in 2-ish parts, but we can get several hundred copies of them. We've already talked about who our different mascots are, so that's okay, we won't focus on that. So what is in the JVM stack trace? So if you happen to be working with someone who's working in Java or Scala, they get a relatively normal stack trace. They might get a Java stack trace wrapped inside of another Java stack trace just because they don't want to get lonely. But for Python people, you get a Python stack trace wrapped in a Java stack trace, wrapped in a Java stack trace, wrapped in a Python stack trace is the normal thing. And so that's like this onion that we get to unpeel, and then we also normally get 400 copies of it if we're running on a 400 node cluster, which now that I don't pay for cluster resources because I work at Google is the size I run on. But you know, it's pretty much take number of nodes, multiply by 2, and then multiply by, yeah, and then sadness. Anyways, cool. So let's make a simple error and look at how it's terrible. Yes? Yes, happiness is overrated. Okay, so we take a genuine big data collection of 10 elements. We add the number 1 to it because Python is well renowned for numeric computation. We wouldn't want to do this in Java. And then we divide by 0 because that seemed like a great idea. And then we ask Spark to count it. That's okay. Oh dear. Oh dear. Okay, so we run this code. And we get a 400-line error message, give or take, depending on the size of your cluster and some other configuration issues. And if we look at this error message doesn't seem to say anything useful. It says that something has gone wrong inside of worker.py in main. And we divided by 0, so that is probably not actually an error in worker.py. That is probably something inside of my own code. And if we're working in Jupyter, we don't even get that. Yeah, the error messages were so useless. I looked up how to disable error reporting in Jupyter. Is what someone told me at PyData DC. I felt really sad. And then now just please upgrade to Spark 2.2 or 2.3. And now you can actually get, you'll still lose some of the log messages, but we pass more of the useful information through to Jupyter. So if you're using an old version of Spark and you're trying to debug it, the first thing to do is upgrade Spark, because that will definitely not break anything else. And then your error messages will make a little more sense. But I think it's useful. Anyways, alternatively, you can go into the terminal, and that's where a lot of the error messages end up going. And this is the terminal where you launch Jupyter, unless you were using something like Jupyter Hub or a commercial solution, in which case I sincerely hope that your commercial provider has exposed these log messages to you in a way, and if they haven't, yell at their support team. Well, not yell, politely ask that they tell you what happened. Oh yeah, and that possible fix is never happening. Okay. So that's depressing. Maybe Spark's WebUI will be easier. So we can go ahead, we can open it up, and then we can look at this error message. And the text is kind of small, but once again, I assure you it contains no useful information, so don't feel bad. But we can maybe click on the thing that failed, right? That's a good idea. There's a blue thing. That is also blue, but that blue one we want to click on, not the captioning. Okay, so we click on it, we go in, and it also doesn't tell us anything. Okay, but it now shows that this task has failed on all of them. And so we know that this probably is a deterministic failure. It's not based on the data. I probably have something really wrong, or Spark is doing something really wrong. I can also apply the wonderful heuristic of scroll not quite to the bottom of this error message, and then I may find my Python stack trace. Yay! And that says like, file, high performance Spark, bad underscore PySpark, line 32, integer division or modulo by 0. Ooh. So all we had to do was, essentially ignore a lot of Java messages. And sometimes that will work. You can essentially just ignore the Java stack traces and your life will be okay. And on those days, you are a lucky person. I mean, you may not feel lucky because you have 400 error messages, but I assure you it gets worse. Wait, that's not what I'm, sorry. Wait, why is the clicky thing? There we go, okay. We can also go through the console logs. Okay, so maybe you noticed that in the Spark WebUI, there was this kind of diagram. And Scala people might actually tell you, what I do is I look at the directed acyclic graph. And that's a fancy way of saying I look at some boxes with arrows. And the arrows have a direction associated with them, also known as I want to publish research papers, whatever. The only problem is in Python, instead of showing like we had two maps, it just says you did a thing. And we knew that we did a thing. We got a stack trace from that thing. But it doesn't show me what was inside of it. So why does PySpark not show us what's useful, what's inside of it? So we do this really cool thing to make your code faster at the slight cost of debuggability, which is a totally reasonable decision, right? It's not like we spend 80% of our time debugging our code. We all know that it mostly works. That's sarcasm, by the way, for the international audience. So essentially what happens is when we put two lambda expressions next to each other, or we essentially have two things that we're doing inside of PySpark, Python land says, hey, this will be so much faster if I lie to the JVM and I just tell them I'm doing one thing. And I'll just put these two things together and it'll be faster because I don't have to copy my data or talk to the JVM, and I can just put these two things together and it'll go faster. And it's true, it does go faster. The only problem is I don't know which part of it went wrong. And I could have hundreds of these things glued together. Sometimes the stack traces are useful. In this case, the divide by 0 really nicely matched up with our divide by 0. Sometimes we don't divide by 0, and we do something that could have come from many of our functions, and that becomes a little more confusing. So take one and count are your friends, and there's this other thing that we can do, which is called persist. And so essentially, we can go in and we can tell Spark that we want to keep some information around. And by doing that, what will happen is Python will say, oh, it's really important that I save this intermediate step. And so it'll compute that intermediate step, and it won't pipeline it together with something else. And then our graph will actually start to make sense, and when things go wrong, we can actually see what's happened because they're separated out into separate stages. The only slight problem is this uses a whole bunch of memory, and Tubbs is our friend who eats all of the memory, and then our computer crashes. And normally, we do a good job of managing our cache, but it's possible that your problem was caused by memory utilization, in which case, all this will do is shift your problem somewhere else, which is great for debugging. Okay, before we go further, I want to say something. And I love lambda expressions, right? I took that one class where they taught me scheme once upon a time, and I was like, this is so cool. But yeah, at some point, you'll find yourself debugging a lambda expression that comes from a file, or maybe doesn't even have a file name associated with it. And Spark is just like, there is an error inside of an anonymous function. I don't know where it is. Good luck. And that's not a lot of fun. So all you have to do is, when you find yourself in this debugging situation, is start to take your lambda expressions and factor them out into named functions. And I know this can make our code feel less elegant, but it'll make it easier to debug because it'll have names for things, and then we can go find those things in our code. And you can also write tests. It's normally a good sign when we have to debug something. It's time to write tests for those functions too. And there's a library which is available on pip and Maven Central if anyone happens to hang out with Java users. No judgment. Spark testingbase. I think it's pretty cool. It doesn't have hypothesis or anything like fancy integrated with it, but the Scala side has something similar to hypothesis integrated in it, and I want to make it work, but ooh, I have 5 minutes. We're gonna skip testing. That's fine. That's what we all do. Okay, cool. So we looked at this architecture diagram for PySpark, and we said, you know what, this is kind of slow. I'm going to trade off understanding what I'm doing again for making it faster. And we added this thing called Apache Arrow. And if you believe vendors, it is 242 times faster. Do not believe vendors. I work for one. Anyways, so what we can do is instead of writing like normal lambda expressions, we write them in this other way, and then we can add two numbers together. And we can add two numbers together faster for things that we won't bother getting into. But then when it goes sideways, whoa, yay, okay. So for example, here I think I returned a floating point rather than an integer, and I told Spark that I was going to return an integer. And so this actually gives us a relatively useful error message. Now admittedly, to get to this part, I have to go through pretty much everything in the Java stack traces and throw them out, and just look for the magic phrase org.apache.spark.api.python.python exception. And that's the part which tells me what actually went wrong. And so, yeah, this error message isn't great. We misspelled the word function, and it wasn't actually expecting a pandas.series, it was expecting an integer. So this error message, it's better than normal, but it's still kind of bad. But if you want to come help us fix it, we're open source. Patches welcome. And seriously, I would love to help anyone that wants to fix this bug, because I don't want to. Right, so that's what we do. We look for this, and then if we can't find it, we throw our hands up in the air and are sad people. You probably want to add logging, but let's focus on out of memory, because we're running out of time. So sometimes we get like Python out of memory. That's fine. Other times we get pure JVM out of memory. This can happen for all kinds of reasons. And we can also get application overhead exceeded. Yay! Has anyone got that? Lovely. There is a magic parameter that you just need to tune called like yarn.applicationmemory.overhead, and just set it to a different magic number and do this until your code works. I just double it until my software works, or it gets really close to 1 and then I go back and think what's going on. So these are all of the reasons that we can get a JVM out of memory exception. All of these are really, really hard to debug. But if you get a JVM out of memory exception, these are the things to look for. And you can look in the Spark WebUI and see if one of them are happening. Python worker ooms, hopefully you can debug because you have more Python experience. But there's a good chance that you don't want to look at 400 copies of your stack trace. Oh, the one error message in Spark that I think is good is from MapReduce. And its input path does not exist. And yes, it is a Java exception from my Python code, but it tells me that my input path does not exist. And this is useful and nice. Okay, so connecting Python debuggers. So we have a cluster. We have many machines. We want to connect and make happiness. You can choose whichever thing you want. You have to use this kind of hacky pattern with a broadcast variable and a singleton, but then you can connect your Python debugger and you can debug that single local instance. Alternatively, you can sample your data and run it locally and see if it still fails locally. And if it does, you've turned from having debugged 400 machines to 1, and your life is so much better. Trust me, if the last one works, your life is amazing. By the standards of distributed systems, which are, once again, down about here. Okay, key takeaways, everything is terrible. After you've debugged your code, please test it. Do not feel bad that everything is terrible. It is not your fault, it is my fault. Oh yes, buy several copies of my book. You can buy it from Amazon. Each copy of a book covers about a quarter of a cup of coffee in San Francisco, and you can help a developer from turning to a life of enterprise support contracts. Okay, you can come join me in other places, but I'm pretty much out of time, so okay, thanks, bye. Do we have time for a question or no? Oh, okay, cool. I thought I was totally out of time. But if anyone has questions, or if anyone brought a printed out Java stacktrace, which once happened to me, there are one microphone? Okay, there are 2 microphones, and you can line up and ask questions, and people can hear you, or you can come and find me, because I'm wearing a bright pink dress afterwards if you don't want to share your Java stacktraces with everyone, which I understand Java stacktraces are kind of sad. Okay, no one wants to share their Java stacktrace today. But thank you all for listening, and I hope this helps.